This topic is called Naming and Finding the Measure of Central Angles, Inscribed Angles, and Arcs of a Circle. It's a topic in ALEKS. And what we're going to do is we're going to kind of establish the protocol that everyone's supposed to use when you quote-unquote name a certain angle or an arc. Naming it just means using the letters to describe it, but the order of the letters matters. All that sort of stuff is important, so that if everyone does it the same way, people will know what you're talking about and you'll know what they're talking about, which is important. So before we get into the problem of that beautiful circle that I've drawn there, which is not drawn to scale, we're going to talk about some of these things. A semicircle is basically you're talking about, you want to use 3 letters when you go to name it, and you're going halfway around. So you want to think about that. We'll talk about that. So you want to use 3 letters when you go to describe it, and you want to go halfway around. Technically what you're doing is you're naming the diameter that you're there, but you also have to have a letter in between. For a major arc, I would say that you would use 3 letters again, and this time I would go more than halfway around. So make it bigger than 180 degrees. 180 degrees is halfway around, 360 is the total of the circle. For a minor arc, you only need 2 letters to quote-unquote name it or describe it. And I would make it less than 180 degrees, so make sure you don't go that full halfway around. Make it a little bit shorter. Central angle has its vertex on the center, and an inscribed angle has the vertex on the circle, on the actual circle itself, not inside. Okay, there we go. All right, so now let's look at this problem. Semicircle. So we want to use 3 letters, and it wants to go halfway around. You actually have more than one correct answer for most of these. So for a semicircle, I would start at I, and we're thinking about as we walk around. I'm walking through H, and I'm going to G. So it's I to H to G. That would be one. We want to put a little arc over it. Another potential answer for that could have been I to J to G. We could have also gone around this way. It's still halfway around, so it's legit, and we're naming it with 3 letters. A major arc, we want to use 3 letters, and we want to go more than halfway around. So again, this time you have a little bit of choice again. I'm just going to start with my semicircle. I'm going to start at I, and I'm walking around. I'm going to do I to H, and I'm not going to say G because I'm only halfway around. I'm going to go one more. I don't need to name all those letters there, so I'm going to name it I, H, J. I want to actually put that back and use black. So I, H, J. You would be completely correct if you had named it I, G, J. That's another way to name it. You could have named it I to J to H. There's there's many ways to express 3 letters where you're going more than halfway around. You don't even have to start with I. So there's plenty more ways to get that one right. A minor arc, short and sweet. Find 2 letters that are next to each other. Make it a nice, short, sweet arc. So my pick would be GJ. Looks nice and short, very sweet. You could have also said GH. You could have said HI. Any of those is fine. So now we have the arc of GJH. So GJH, and I gotta find it. So it starts here at G, goes to J, and goes almost all the way back to the beginning of G, but doesn't quite hit there. So we almost went 360 degrees all the way around, but we didn't go through this. So if I know that I go 360 degrees to get all the way back to the beginning, but I didn't go through the 120 arc, means when I subtract those 2, I get 240 degrees. The last piece they're asking for in this problem is GFH. Again, I need to find it so I know what I'm talking about. So here's G, it goes to F. So we're talking about an angle now. And this here is called the central. It's a central angle because our vertex, which is your F, is on the center of the circle. So this is your central angle. Central angles equal the arc. So if we have an arc that it intercepts of 120 degrees, this angle also has to be 120 degrees. I really like those. For the inscribed angle, I didn't talk much about that, but here's an example of an inscribed angle. It's right here. It goes where the vertex here is on the circle itself. So that would be the example of an inscribed angle. The relationship between its arc and its angle, if this here was 40 degrees, the angle inside would be half that, and it would be 20. So you might be maybe making some notes. I would maybe write this stuff here down. That would help kind of give you a boost up. Again, it seems really nitpicky, but it's the only way that we can all make sure we're talking about the same thing and naming things the same ways. So, all right.